All right, so naming some organic compounds, drawing structural diagrams. This is the quick video key. You can see it all on the screen, but really quickly, we went through the red stuff at the top in class. Number 5, 3,4-difluorocyclopentene. Automatically, when we have cyclopentene, one of the carbons in the double bond gets a number 1, and so it's 1, 2, 3, 4, and away we go. And I've drawn it as a line structure formula as well as over here with a more condensed structural formula. Note, of course, that this and this are just a carbon attached to 1 hydrogen and 1 fluorine. All right, number 6, 2,2,4-trimethylpentane. Line structural formula there. Regular structural formula over here, condensed structural formula over here. Ethylbenzene, again, line structural formula, condensed structural formula there. 1,2-dimethylbenzene, line structural and condensed structural. And then I gave a bunch of isomers of C5H10. There might be more. These were the only ones I could come up with quickly. So we have cyclopentane, methylcyclobutane, 1,2-dimethylcyclopropane, 1,1-dimethylcyclopropane. All of those would have C5H10. Pent-1-ene, pent-2-ene, 2-methylbute-1-ene, 2-methylbute-2-ene, and 3-methylbute-1-ene. Notice that the double bond always gets priority with the numbering. That takes us on to the next page. Again, some of this we did in class. So red stuff at the top, those two were done in class. When we look at number 3, 1-methyl-3-propylbenzene. Methyl, M comes before P, so it gets the number 1. When we look at this one here, again, that triple bond gets numbering priority. So it's between 1 and 2. So we have a pent-1-ine. And then we've got 1, 2, 3, 4, 5 carbons. So it is, yeah, pent-1-ine and 3-ethyl-4-methyl pent-1-ine. Again, ethyl comes before methyl. Number 5, in this case, we don't have a nice way to name all, whoops, settle down there. We don't have a nice way to name all of this as a branch. And so we have a pentane, a 5-carbon chain, with a phenyl branch and a methyl branch. And again, methyl comes before phenyl. So alphabetical, there we go. Number 6, cyclopropene. We do not need to have that as like numbering because there's only one way to have cyclopropene. And then the last ones here, a couple ways you can do this. I did the first one kind of the quick cheater way. I looked and said pentane, that's 5, methyl, that's 1, so 6 carbons. It is an alkane, so I know that the general formula for an alkane is CnH2n+2, which means if N is 6, I have C6, and then H is going to be 2 times 6 plus 2, which is 14. I could also draw that one out and start counting hydrogens. With 1,4-diethylbenzene, I can do this kind of the same way. It says, okay, benzene is 6 carbons. Each of the ethyls is 2, so there's 2 of them, so a total of 10. In this case here, I recognize that each ethyl is 5, and there's 2 of them, so that means only 4 of the benzenes have a hydrogen. Honestly, that way is more confusing than just starting to count. So again, I drew my line structural formula here. I counted out hydrogens first of all. That's the little circles. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then at that point, I put numbers next to them just in terms of how many hydrogens on each of the carbons. And so 3 and 2, that's on each of the ethyls. So 5 on each, so grand total of 10. And then we've got 1, 2, 3, 4 more attached to the benzene ring. And so there we have it, C10H14. Thanks.